Hello everyone. This video would focus on conic section, specifically on ellipse with center at the point of origin or at 0, 0. And this is the fourth part. In this part, we're supposed to determine the standard equation of an ellipse given the coordinates of the two vertices and the coordinates of the two co-vertices. Before we go over this example, let's have a review on the parts of an ellipse and the two cases of an ellipse with center at 0, 0 or at the point of origin. We remember that there are two cases of an ellipse. The first case here is the horizontal ellipse. Before we go over this case, let's have the parts of every ellipse. The first part that we have here is the center. The center is halfway between the two diameters of the ellipse. The second part that we have here is the major axis. The major axis is the longer diameter of an ellipse that connects the two vertices passing through the center. So this means that both of these two dots that we have at the end of the major axis are the vertices. So one is the vertex and the other is the other vertex. The plural for that is vertices. So pretty much vertex is the end point of the major axis. Now we also have another diameter which we call as the minor axis. This is the shorter diameter of an ellipse that connects the two co-vertices of an ellipse passing through the center. So this point right here is a co-vertex of an ellipse, and this point down here is also a co-vertex of an ellipse. The next part of an ellipse is focus. So these 2 points right here are the focus of the ellipse. The plural for focus is foci. This focus is always gonna lie along the major axis. Please remember that foci of an ellipse are two fixed points on its major axis such that the sum of the distance of any point on the ellipse from those 2 points is constant. So those are the basic parts of an ellipse. Now we also remember that we have what we call as the semi-major axis. This is half of the major axis. So that means this runs from the center to the vertex, and we are going to represent this as A. On the other hand, we also have what we call as the semi-minor axis. This is half of the minor axis, meaning this connects the center to one of the co-vertices. And this line segment from the center to the co-vertex is represented as letter B. Now, on the other hand, from the center to the focus is represented as letter C. Now, using these letters A and B, we can derive the equation of a horizontal ellipse. Now, using these lengths A and B, we can come up with an equation of a horizontal ellipse, and that is x squared over a squared plus y squared over b squared is equal to 1. Now, notice that our A is the longer value, because this is actually half of the major axis, which is the longer diameter. Now, notice that our A, which is the longer value, is the denominator of x squared. This means that if the denominator of x squared is bigger compared to that of the denominator of y squared, that means that we can come up with a horizontal ellipse. Now, we also remember that our A value, which is the semi-major axis, will always be greater than B, which is the semi-minor axis. That's always, every time. And the equation that can be used to determine the length of C, that is from the center to the focus, is C squared equals A squared minus B squared. Now, let's look at the second case of an ellipse. For the second case of an ellipse, we pretty much have the same parts. The first part is the center. Again, this is halfway between the two diameters of an ellipse. We also have a major axis. This is the longer diameter of an ellipse that connects the two vertices passing through the center. Now, please notice that we call this as a vertical ellipse because the major axis is the vertical line segment. We also have the parts which we call as the vertex. There are two of them. We call them as the two vertices. These are the two endpoints of the major axis. We also have a minor axis, that is the shorter diameter of an ellipse that passes through the center and that connects the two co-vertices. And again, along this minor axis, we have the co-vertices or the co-vertex if it's singular. These are the endpoints of the minor axis. Now, we also have another part which we call as focus. So these 2 points right here are our foci. So pretty much these are the parts of an ellipse. So it doesn't really matter if it's a vertical ellipse or a horizontal ellipse. The parts would still be the same. Now, we also remember that we have what we call as the semi-major axis. This is half of the major axis, which means this connects the center to the vertex, and we are going to label this as A. On the other hand, we also have what we call as the semi-minor axis. This is half of the minor axis, which means this connects the center to the co-vertex or one of the co-vertices. And we're going to label this as our B. Now, we also remember that the distance from the center to the focus is represented as letter C. Now, using these lengths A and B, we can therefore say that our equation for a vertical ellipse is x squared over b squared plus y squared over a squared is equal to 1. Now, notice that our a squared is under the y squared. This means that if the value under, or if the denominator under the y squared is bigger than the denominator under the x squared, we are able to get a vertical ellipse. And we also remember that, again, our A is always greater than B. Now, to determine the length of C, we are going to use the equation C squared equals A squared minus B squared. So these are the parts of an ellipse, and these are the two cases of an ellipse. Now, let's go back to the problem. Okay, going back to the problem right here, we're supposed to determine the standard equation of an ellipse given these two vertices. So I'm going to go ahead and plot these two vertices right here. So we're going to start with 7, 0. So it's going to go 7 and then 0. This is our first vertex. I'm going to label that as V. Negative 7, 0 would be down here. So this is our other vertex. Now, we also have the co-vertices. We have 0, 5. So this is the first co-vertex. And then the other co-vertex is at 0, negative 5. So it's going to sit here. So I'm going to label this as co-vertex. Now, looking at this, we remember that the center of every ellipse is the midpoint between the two vertices or the two co-vertices. So looking at this sketch that we have right here, we are supposed to determine the midpoint between these two vertices. We can use the midpoint formula, or we can just go ahead and count it to determine the center. And then from here, we can go ahead and say that our center is at 0, 0. Again, we can use the midpoint formula to determine the center. So our center is at 0, 0. And looking at this, our ellipse is elongated along the horizontal axis. So that means we are able to form a horizontal ellipse. So I'm going to go ahead and write that information right here. Okay, since we are able to form a horizontal ellipse, we can go ahead and say that our A squared is under the X squared. So then I'm going to go ahead and write the general equation of a horizontal ellipse down here. Okay, so the reason why our A squared was placed under the X squared, because again, we have a horizontal ellipse. So we need the value for A and we need the value of B. So that we can go ahead and say that we remember that if we say co-vertex, that is the point that we have up here, or it's either up here or down here. Now, we remember that the distance from the center to the co-vertex is our B. Counting the distance between this, we can use the distance formula for this, but we can just go ahead and count it. 1, 2, 3, 4, 5. So our co-vertex, or the B value, is 5, and that is the distance from the center to the co-vertex. So I'm going to go ahead and write that value down here. So our co-vertex is actually our B, and that is a plus minus 5. Now, since we know the location of the vertex is right here, we can determine the value for A. A is the distance from the center to the vertex. We can go ahead and use the distance formula to determine the value for A, or we can just count it. 1, 2, 3, 4, 5, 6, 7. So our A then is 7. So I'm going to go ahead and write that down here. So A is plus minus 7. So we went, the negative 7 would go to the left from the center, and then the positive 7 would go to the right of the center. So that we can go ahead and plug this value into this general equation that we have right here. So this comes out x squared over our a squared is 7. So I put in here 7 squared plus y squared over our b is 5. So that is 5 squared equals 1. So then we can go ahead and say that the equation for this problem that we have right here is x squared over 49 plus y squared over 25 equals 1. This is the equation of this ellipse given these conditions that we have up there. Now we can go ahead and sketch the ellipse right here. Okay, but we have to determine the location of the two foci. We remember that the location of the focus is c distance from the center. And so we can use the equation c squared equals a squared minus b squared. So I'm going to write that up here. So c squared equals a squared minus b squared. So we are looking for the c, which is the location of the focus. So c squared equals our a is 7, square it, minus 5 squared. So this is c squared equals 49 minus 25. Subtracting 49 and 25, this will give us 24. So c squared is equal to 24. We wanted the c because that's the location of, or that's the distance from the center to where the focus is. So we need to square root both sides. So this comes out, c is equal to plus minus square root of 24. We can go ahead and simplify this further. So c is equal to plus minus square root of 4 times 6. And the square root of 4 is 2. So that we can go ahead and simplify this further as plus minus 2 square root of 6. And if we change this to decimal version, this is 4.90. So that's plus minus 4.90. So that means our focus is located 4.90 to the left and 4.90 to the right from the center. So this is where our focus is gonna sit. So that's the first focus, and we will approximate it down here as well. So this is the other focus. So these are the location of the two foci. So I can go ahead and write the coordinate of the two foci down here. So we have solved this problem up here. So this is the equation of this word problem that we have here. And this is the graph of this equation that we have down here. Now let's move on to the next example. At this time, I would encourage you to pause this video and try this problem out on your own. And when you're done, unpause it and check your answer. Okay, so we go over the problem here. We're supposed to determine the standard equation given this vertices and the co-vertices of that ellipse. I'm going to go ahead and plot these 4 points on the graph. Okay, now we remember that the center of an ellipse is the midpoint between the two vertices, or the midpoint between the two co-vertices. So I'm going to go ahead and trace the center here. Again, we can use the midpoint formula to determine the midpoint of the two co-vertices. But if we trace this, our center is located at 0, 0. So I'm going to go ahead and write this as our center right here. Now, looking at this, we can tell that our major axis is the vertical line segment. So then we can go ahead and say that this is an example of a vertical ellipse. So I'm going to go ahead and write that information up here. Since this is an example of a vertical ellipse, I wrote the a squared at the bottom of y squared, since again, that is the vertical ellipse. So this is the general equation of a vertical ellipse case. So that we can go ahead and say that our co-vertex is actually located B distance from the center, and our vertex is located A distance from the center. So I'm going to go ahead and write that down here. So co-vertex is has a distance of B from the center, while the vertex has a distance of A from the center. So if we count it, our co-vertex is located 6 units from the center. So I'm going to go ahead and write that up here, plus minus 6. While our A, which is the distance from the center to the one of the vertices, we can count it, and that's actually 9. So this is our B, and this is our A. We start from the center to the co-vertex, that's the B. We start from the center to the vertex, that is the A. So if we count it, that's actually 9. So I can go ahead and write that up here, plus minus 9. So that we can go ahead and plug the value for B into this equation and plug the value for A into this equation. So this equation for the vertical ellipse is going to look like this. Okay, so this is the equation for this problem that we have up here. Now, we are supposed to determine the focus or the two foci. We remember that the formula is C squared equals A squared minus B squared. And C is the distance from the center to the focus. So I'm going to go ahead and write that formula right here. Okay, so our focus again has a distance of C from the center. So in this case right here, we got a value of 3 square root of 5 is the value for C, or that is approximately 6.71. So then from here, we can go ahead and say that our focus is located 6.71 up from the center and 6.71 down from the center. So I'm going to go ahead and plot that up here. So these are the coordinates of the two foci that we got up here. And so we can go ahead and sketch the ellipse. Did you get the same answer as this? Good. Perfect. If you found this video helpful, hit like and subscribe for more math videos. See ya!